A very flexible chain of length is L and mass is M. Vertically suspended with its lower end just touching the table. If it is released so that each link strikes the table and comes to rest, what force the chain will exert on the table at the moment Y part of the length falls on the table? Initially, a chain is at vertical position. This chain has number of links and mass is distributed uniformly. Length of this string is L and mass is M. So whenever the mass is distributed uniformly, take mass per unit length. This chain touches the top of the table. When this chain is released freely, then it exerts a force on the table and finally comes to rest position. Total length is L. This small part length is Y. So when this chain is released, Y part of the chain comes to rest position and the remaining part in vertical direction only. So this length is Y and the remaining part is L minus Y. Here we have to calculate how much force exerted by this Y part on the table. This small part exerts two different forces on the table. One is because of its own weight. Mass of Y part of the chain, My is equals to mass per unit length into length of the chain, M by L into Y. Initially, this chain is at rest position. So, after release, this chain possesses acceleration due to gravity. Due to that, the speed of the chain increases and due to that, its momentum also changes. So, the second force is due to change in momentum. dP by dt. Final momentum minus initial momentum. Initially, chain is at rest position. So, initial momentum is equals to 0. d by dt of final momentum, mass of Y part into final velocity. Here we know mass of the chain, mass per unit length into Y. And Vy is equals to square root of 2gy. We know the final velocity of a freely falling body when it released from h height, v equals to square root of 2gh. Here height is nothing but length of that part, that is y. v equal to square root of 2gy. Mass per unit length is constant, m by L. The rate of change of displacement is called velocity. So, in place of dy by dt, take Vy. M by L into, we know Vy is equals to square root of 2gy. So, square root of 2gy into square root of 2gy becomes to 2gy. 2mgy by L. So, now take the total force exerted by the Y part of the chain on the table. F equals to F1 plus F2. F1 is equals to weight of the chain, M by L into Y. This is mass of the chain into acceleration due to gravity, plus F2 is equals to 2mgy by L. LCM is L. mgy plus 2mgy equals to 3mgy. The force exerted by the Y part of the chain on the table is 3mgy by L.